Hello class, so in the middle of me recording for 12.4 it cut off, so I refuse to rewrite all this again, but I will walk you through what is happening. So in 12.4 we're talking about the volumes of prisms and cylinders. And so our two definitions are volume, and that is the number of cubic units contained in the interior. So this is everything that's going to be contained on the inside of the prism or the cylinder that we're discussing. Now the Cavallari's principle is if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So this is where we're comparing two figures, and we will see example of Cavallari's principle later on. Now we have two core concepts, and that's the volume of a prism and the volume of a cylinder. So the first core concept is the volume of a prism. So volume is B times H. So capital B, remember, is the base area. So the base area is whatever the base that we're discussing in the area of that particular base. So for example, the base area of this prism would be a square. So this still works. Even if it's slightly slanted, the base area is still going to be that square, given that all the sides are equal. So for our first example, we have a triangular prism. So the triangular prism has the base area is a triangle. So if we want to find the volume, we have the base area times the height. Now we need to find the base area by finding the area of the triangle. So the area of the triangle is the base times the height. In this case, it's 3 and 4. So 1/2 base times height gives us 6, because 12 divided by 2 gives us 6. So now we have the base area. We can plug it in here, and then we have our height, which is 2. And so 6 times 2 gives us 12 cubic centimeters for our triangular prism. So I know that is a lot, however, it is super simple if you know what your base is to begin with. Once you find the area of that base, everything else will be so much smoother. So for the next example, we have a trapezoidal prism. So again, a base is the trapezoid. So again, we're doing base area times the height, but the base area is the trapezoid. And the area of a trapezoid is 1/2 times base 1 plus base 2 times its height. So we're going to add our bases, and in this case, it is not 16, it is 6. So we have 6 plus 14, and then we're multiplying by 3 in this case as the height, not the 5. We won't multiply that 5 yet. And so we end up with 30 centimeters squared. So now that we found the base area, we're going to multiply that by the height of the prism, which is 5, and we end up with 150 cubic centimeters. So that is an example of finding the base area and finding the volume of the prism. So now on to the next page, we're going to find the volume of a cylinder. So picking up where I left off, we were talking about the volume of a cylinder. So remember, cylinders have circles on them, so this is why I circled the pi r squared, because that is the area of a circle. So we're just going to plug in where it's needed. So if we want to find the volume of both of these things, so the volume for this particular cylinder is pi r squared times the height. And so we know that r is 9. So we have 9 squared times the height, which is 6. So we have 9 squared is 81 times the 6. We have 486 pi. But if you want to put this into a decimal, you end up with 1,526.81. So that is the volume for a cylinder for this example. So now if we're going to do the next one, we have pi r squared times the height. We know that r is 4, so we have 4 squared times the height, which is 7. So if 16 times 7 gives us 112 pi. And as a decimal, we end up with 351.86. So those are two examples finding the volume of a cylinder. So now we're going to move on to the bottom part of our notes, which discusses extra practice. So So exercise 1 and 2 says find the volume of the prism. So again, we are talking about the volume of a prism. So remember, volume is the base area times the height. And the base area of this is actually the triangle. So B is going to be 1/2 the little base times its height. So 1/2 times the little base. The little base is going to be 3, and the height is 1.5. So plugging that all in, we have 3 times 1.5, and then divided by 2, you end up with 2.25. So 2.25 is the base area, and now we have to multiply it by the height. So 2.25 times the height, in this case, is 5. And so 2.25 times 5 is going to give me 11.25 cubic centimeters. So there is number 1. Now if we're going to move on to number 2, we have a pentagonal prism. And I know it's pentagon because we have 5 edges here. So, and lucky enough for us, number 2 already gave us the area of the base. So we have already done the extra part. So we have the base area times the height, but the base area is already given to us as 10. The height is 4, so we have 40 cubic inches. So 40 cubic inches for number 2. If you turn to the next page, we will continue on to do some more examples. So on to number 3 and 4, we are still finding the volume of the cylinder. The volume of the cylinder, that formula is using pi r squared, so the area times the height. So in this case, for number 3, the volume, we have pi, and r in this case is 2.5 squared, and we're multiplying by the height, which is 7. So putting that all together, I end up with 43.75 pi. So if I did 2.5 squared times 7, I get 43.75 pi. And as a decimal, you end up with 137.4 rounded to the 10th place. So we'll do the same thing for number 4. So number 4, we end up with pi, and then 2 squared is the radius, or 2 is the radius, and the height is 11. So you have 138.2 if you're not talking about pi. If you wanted everything before pi, you have 44 pi is 4 times 11, and then you can convert. Alrighty, so that is numbers 3 and 4. So number 5 and 6, we need to find the missing dimension of the prism or cylinder. So the volume is already given to us, and this is a prism, and then we have a cylinder. So let's do the prism first. So we know the prism, we have the base area times the height. And we know the base area is a rectangle. And we're missing the width of the rectangle. So if we were to redraw this, I have y, and then I have 18. I am missing the y. So our volume is given to us as 661.5. And then the base area would be the length times the width. So base area would be 18y, or 18 times y. So I have 18y, and then the height is 3.5. Okay, so I'm going to multiply 18 times 3.5. So 661.5 is equal to 63y. And now if I want to solve for y, I'm going to divide by 63. And if I do 661.5 divided by 63, that means the length would be 10.5. Okay, so So that's finding a missing dimension for a prism. Now we're going to do the same thing for a cylinder. So for a cylinder, remember our volume is going to be pi r squared times the height. So the volume is already given to us as 75.36. Now I still have the pi. I don't know what the radius is. That is what p is. So we have p, and remember this is squared, and then the height is 6. Okay, so I'm going to go ahead and divide by 6. Or if I did 3.4 times 6. So let's do that. So we have 75.36. It's just another way of doing this. So I have 6 times 3.14. That is what pi is. The little symbol for pi, so you know what that is. And then I have p squared. Okay, so I have 6 times 3.14 is 18.84. P squared, and this is 75.36. Now if I want p squared by itself, I'm going to divide. So I'm going to divide 18.84. And if I type that into the calculator, I have 75.36 divided by 18.84, and I end up with 4. So 4 equals p squared, but I want p. So I'm going to square root both sides. So p equals 2. The radius is 2. So that is number 6 on trying to find a missing dimension involving pi. And again, I use 3.14 for pi. If you decide to use full decimal, you might be a little skewed on whether you get a perfect 2 or not. So keep that in mind. So now, moving on to 7 and 8. So it says, describe how the change affects the volume of the prism or cylinder. So this is very similar to what we did in Chapter 11 when we discussed the effects and changes of the area of certain polygons. So now we're going to do the same thing with cylinders and prisms. So the volume of this cylinder, this is a cylinder, the original volume we know is pi r squared times the height. We know that I have 2 squared and the height is 6. So I end up with 24 pi. Okay, so now it says, what happens if I multiply the radius by 5? So I multiply the radius by 5, that means the new radius becomes 10. So the new one, and I put a prime, is 10 squared times 6. And I end up with 600 pi. So now I know I'm increasing because it is a whole number. So I end up with 600 pi all over 24 pi. The pi's are going to cancel out, and 600 over 24 gives me 25. So 25 times bigger. Our last example is number 8. You're multiplying the length and the width by 1/6. Okay? So no, I'm going to be reducing because it's a fraction. It's less than 1. So if it's bigger than 1, I'm increasing. If it's a fraction or less than 1, I am decreasing. So let's find the volume of this prism, which we know is the base times the height. And if we want to find the base, my base is a rectangle. So it's 18 times the 12. So you end up with 18 times 12. Which is 216. So 216 times the height, which is 3, gives me 648 centimeters. Okay? So then, what happens if we multiply the length and the width by 1/6? So if we did 1/6 and 1/6, not the height, just the length and the width. So that turns this into 18 divided by 6 gives me 3. And then 12 divided by 6 gives me 2. So my new dimensions are 3 and 2. So my new volume with my new base area, so the new base area is going to be 3 times 2 now, which gives me 6. So base area is going to be 6 times the height, which is still 3. So I have 18 centimeters. And because there's a fraction I am decreasing, in order to find that scale factor, I'm going to do 18 over 648. and I end up with 1 over 36 times. Okay? And this is a decrease. So 1 over 36 is that scale factor. And that is our last example for 12.4. Thank you so much for watching my video. If you have any questions, please feel free to email me, as well as my tutoring hours are Wednesday and Thursdays from 3 to 4, as well as every morning at 6:50. Thank you so much.